Hello and welcome everyone. I hope you are doing well. Today's lecture we're going to talk about one of the most important parameter in power system, which is the temperature effect. So go get your drink and let's begin. Today's lecture we are going to understand the effect of temperature on the open circuit voltage and short circuit current and the output power of any solar cell. And also we are going to understand and estimate the value of the power V curve. So let's begin. In the previous lecture, we understood the relation between the output current and the output voltage of any solar cell. And we understood that it follows this equation. The output current I is equal to IPH minus I node times exchange times exponential of Q times V over KB times T minus 1. As T stands for the temperature, KB stands for Boltzmann constant, Q stands for electronic charge, V stands for the output voltage, I node stands for the exchange current or the saturation current, IPH stands for the photo current, which is depending on the solar radiance and the temperature. When we draw this relationship between I and V, it's going to be like this, with the highest value of current is the I short circuit current and the highest value of voltage as output circuit voltage. When we try to estimate the relationship between the power and the voltage, we can calculate it from the normal equation of the output power is equal to output current times output voltage. So when we put the value of current, we can get the power equal to V times I photo minus I node times exponential of QV over KB times T minus 1. When we draw the relationship between V and P, we actually get something like this. With the highest peak value of power called power maximum, and at this power maximum, we will have output voltage of the solar cell equal to maximum power point voltage or VMPP. At this voltage, we will have a current called the maximum power point current. So we can summarize that the maximum power point current and maximum power point voltage, the operating power or the output power of the solar cell is going to be the maximum power. Okay, now let's understand the effect of temperature on the parameters like open circuit voltage and short circuit current. To understand it, from the basic equation of the open circuit voltage, which equal to Kp times T over Q times ln I photo over I node plus 1, as I node stands for the exchange current or the saturation current of the diode, T is the temperature, Kb is the Boltzmann constant, and Q stands for electronic charge. From the first point of view, you can say with increase of temperature, we will have increase in the open circuit voltage. But it's a big trap for you, as with the increase of temperature, we will also have a high increase in the saturation current of the diode. This is going to cause a big reduction in the output circuit voltage. So we can estimate that the voltage is inversely proportional to the temperature. On the other hand, with large increase the temperature will cause a slightly small increase in photo current, allowing slightly increase in the short circuit current. So when we see the current voltage curve of any photovoltaic cell, we can see it like this. With increase in temperature, we are going to get high reduction in the voltage and a small increase in the current. So the normal curve is going to turn to something like this. And with higher temperature, the higher reduction in the voltage is going to become and the higher increase in current is going to come. Also, with high increase in temperature will cause high reduction in power. So the normal curve of power voltage curve is going to be reduced to be like this. And with higher increase in temperature will cause higher reduction in the output power. So now let's understand what is the basic effect of temperature on open circuit voltage and short circuit current. Before we understand the effect of temperature, you will need to understand some basic concepts like the standard temperature coefficient, or STC, is basically the international industrial standard at which the system performance is determined. It basically can be determined based on three things. First thing, the temperature of the cell is operating at 20 degrees Celsius, and the air mass of 1.5, and the solar irradiance of 1000 watt per meter square. The second parameter is the nominal operating cell temperature, or NOCT. It basically defined as the solar panel temperature and is being determined based on three things: the air temperature, or the surrounding to the cell temperature is 20 degrees, and the air mass of 1.5, and solar radiation on the solar cell of 800 watt per meter square. The last and not least parameter you need to take into account before taking the effect of temperature is the cell temperature. Basically, the cell temperature is going to vary from the surrounding temperature to the cell, as the cell temperature is going to affect by two things: the solar radiation and the surrounding temperature. So the cell temperature is basically determined by this equation: T cell equal to T ambient, or the surrounding temperature, plus G, or the solar irradiance, times NOCT minus 20 over 800. Now, let's understand how the temperature is going to affect the open circuit voltage and power of the solar cell. Basically, it's going to affect like this temperature characteristic table and this equation, which say X equal to X of STC plus dx by dt times T minus TSTC. The TSTC is the standard temperature condition temperature at which you determine the value of the standard open circuit voltage and standard maximum power point current and short circuit current. T stands for the current cell temperature, and X stands for the parameter is going to change, which could be the power, output circuit voltage, or short circuit current. dx by dt is the temperature coefficient of power or open circuit voltage or short circuit current. XSTC is basically the parameter which could be power or open circuit voltage or short circuit current at the standard temperature condition. And the X stands for the new parameter, which could be the power or open circuit or short circuit current. To understand this equation, we will need to understand it with example. So, if we have NOCT of 25 degrees Celsius for any solar panel or solar cell, and the current surrounding temperature in the side is about 40 degrees Celsius, and in the side the solar radiation is 1000 watt, and the standard temperature condition open circuit voltage is 15 volt, at 20 degrees Celsius. This means the cell temperature is going to be 40 plus 1000 times 25 minus 20 over 1000. We're gonna get 46.25 degrees Celsius. This means if you have a solar cell, this solar cell at surrounding temperature of 40 degrees Celsius, this solar cell will have a different temperature from the surrounding of 46.25 degrees Celsius. Due to increase of the temperature from 20 degrees Celsius up to 46.25 degrees Celsius, this will cause a reduction in the voltage by 15 minus 0.131 times 46.25 minus 20. So the new voltage is going to be 11.56 volt. Now you can see the voltage has been reduced from 15 volt to 11.56 volt. Okay guys, now we have understood with increase of temperature and the cell temperature by 26.25 degrees Celsius will cause about reduction in the open circuit voltage by 3.5 volt. Okay guys, that's for today. Thank you for watching. See you in the next lecture. Bye bye.